Imagine a test tells you your biological age is now 3 years younger. Does that mean your body has really gone back 3 years? The short answer is, some age-related changes may improve, but a younger number does not prove that aging itself has been reversed. A younger biological state, a slower pace of aging, and the recovery of a lost biological reverse are 3 different things. So, where do those 3 years come from? Scientists first build a reference curve using data from many people. They look at how DNA methylation, proteins, metabolites, or chemical markers really change with age. Then they compare your results with that reference curve. Imagine a 58-year-old person. Before an intervention, their results look similar to those of an average 58 years old. After intervention, the results look more like those of an average 55 years old. The model may then report a 3-year reduction in biological age. But this doesn't mean that the whole body has gone back 3 years. It means the measurements have moved to a younger position on a population reference curve. Different aging clocks also measure different things. Some clocks ask, what age does your body most closely resemble right now? That is your current position. Others ask, how quickly is your biology changing over time? That is your pace of aging. Your estimated biological age may fall without changing your long-term pace of aging, or your pace may slow before your biological age begins to fall. So, if 2 aging clocks give different results, they may not truly disagree. They may simply be measuring different parts of aging. In human studies, the evidence for slowing aging is stronger than evidence for reversing it. In a calorie trial, 2 years of moderate calorie restriction slowed one measure of aging by about 2 to 3%. But 2 other biological aging measures did not show a clear reduction. The Do-Health trial also found small effects from omega-3, vitamin D, and exercise on some DNA methylation clocks. Over 3 years, the differences were equal to only a few months of biological age. These findings are still meaningful, but they look more like gently applying 2 brakes than making the body travel background. Some small studies have reported reductions of 2, 3, or even more years in epigenetic age. But when we see results like those, we need to ask 3 questions. Was there a randomized control group? Did different aging clocks show the same result? And did the change last and lead to better physical health? In the 2019 TRIIM study, 9 men received a combination of growth hormone, DHEA, and metformin. After 1 year, several epigenetic clocks showed younger ages. It was an interesting finding. But there was no placebo group. And because 3 treatments were used together, we cannot tell which one causes the change. This study can generate a new hypothesis, but it cannot prove that aging was reversed across the whole body. Biological age measurements do not always move in one direction. During infection, surgery, pregnancy, or several physical stress, some measurements may temporarily rise. When the body recovers, they may fall again. This tells us that some biological states are flexible, but a lower biological age may sometimes reflect less inflammation, better metabolism, or recovery from temporary stress. This is still valuable. But recovery is not always rejuvenation. It doesn't mean that accumulated DNA damage, senescent cell, and structural changes in our tissues have all been reversed. The ovary is a good example of why this difference matters. AMH is mainly produced by the granulosa cells of small growing follicles. If the environment around these follicles improves, the cell may function better. AMH levels may also change. A healthier environment may support follicular development and the development of the egg. But AMH is not a direct test of the egg quality. A higher AMH level alone doesn't prove that egg quality has improved. PCOS is a clear example. Women with PCOS may have higher AMH because they have more small follicles. But follicle development may also be disrupted. So higher AMH doesn't always mean a younger or healthier ovary. AMH may also help control how primordial follicles are recruited. In theory, a healthier ovarian environment could affect this process and perhaps slow the loss of ovarian reserve. But we still need long-term human studies to know whether this truly changes the course of ovarian aging. Most importantly, a healthier ovarian state doesn't mean that lost primordial follicles have been restored. The state may improve, the pace may change, but some lost biological reserves cannot currently be replaced. Imagine an intervention changes a woman's ovarian age from 40 to 37. What can we really conclude? Her current measurements have moved to a younger position on the population reference curve. But to show that her ovarian aging has truly changed, we need much more evidence. The change should last. It should appear again in repeated measurement. It should be linked to better follicle development or better ovarian response. And over time, her ovarian reserve should decline more slowly. The same rule applies to whole body biological age. Evidence should move from a biomarker to better physical function. Then, from one measurement to a better long-term trajectory. And finally, to less disease, disability, and death. No biological age clock has completed this full process yet. So, can biological age really be reversed? The most accurate answer is some age-related biological states and physical functions can improve. Some interventions may also slow certain parts of aging process. Research in cells and animals have shown that some of the features of aging might one day be reset, but we're still far from proving that this can be done safely and lastingly in humans. And improving a biological state is not the same as restoring a reserve that has already been lost. So, do not ask only, how many years younger did the number become? Ask, did we change only the measurement? Did we change a biological process? Or did we truly improve the person's future health? The real goal is not a younger number. It is more years lived in good health.